Hello guys, welcome everyone. This is INE's Networking Week. In this session, I want to get you familiar with the Cisco ASA Firewall. We will take a look at how to start with Cisco ASA Firewalls using the command line. I am Piotr Kaluzny. I'm going to run this session for you. I work as one of the instructors here at INE. I am specifically responsible for the security track. In this session, I want to quickly make an overview of the ASA as a platform. I want to give you guys some heads up what a Cisco ASA firewall can do for you. I'm going to cover some basic configurations such as interface settings, routing, traffic control, and also management access. Cisco ASA is an example of an advanced firewall system, advanced network security platform that people typically deploy to control the communication in their network. One of the most important functions of the ASA is its stateful filtering capabilities, plus also some more advanced inspections performed at the application level. Stateful filtering is all about controlling the sessions, the packets coming from the device, and remembering the state of the session that was initiated for the unit, for the system. Just to quickly show you what this technology does, I'm going to make a quick illustration. We will assume that our internal users are going to be connected on the left side of this topology. We will have the firewall in the middle, and I'm going to assume that the ASA is connected to an ISP device, to an ISP router, which has connectivity to the internet. And the thing about stateful filtering is that the ASA is supposed to remember all connections traversing for its interfaces. Like when one of the users, let's say that this is going to be PC1, PC1 is connected to our internal network. It's one of our guys. It's one of the users in the company. And when this guy, let's say, wants to connect to one of the web servers on the internet, it's going to open up a browser, type in the URL, which is going to cause its PC to generate some web packets. And those packets will be obviously sourced from the IP address of this device, and they will be destined to the server. I'm going to skip address information, port numbers, stuff like that. We don't really need to use the actual numbers. The thing is that once ASA gets the packet from the PC on one of its interfaces, it's going to add this information to a special location in the memory called stateful table, or just the connection table. So this table is going to maintain information about the actual connections. It is going to know that PC1 sent a packet to the web server. So when we get the reply from the server, the reply is destined to the PC, or maybe just the translated address of the client. The ASA is going to get the packet on another interface, and it will now inspect the packet to see if it matches one of the connections initiated by our users or not. If it matches, which is our case, it is going to allow the response packet through. Now, if this was a new connection generated by someone else, let's say we've got an attacker, which is targeting our inside devices, you will have a similar situation. The stateful technology allows us to distinguish between those trusted and untrusted packets simply by checking the actual connections in the stateful table. So since the second session is not a match, the second packet is not a match with our connections, we will automatically drop it. Now, there is going to be a method, as we will see, that will allow us to control what sessions, what connections can be initiated from those less trusted zones, less trusted portions of our network. This is something that I will discuss today. I'm going to show you how to do in this session. This was just a quick overview of the stateful filtering technology to make sure that we understand what it does and how it works. Okay, another important aspect, feature of the ASA, its capability, is the VPN gateway function, the VPN termination, which is something that a lot of folks use to provide remote access to our network, so access for individual clients so that they can connect to the internal resources from any place in the world, or maybe to allow access to some other networks via the internet. ASA is a well-known and industry-recognized platform for handling VPN connections. It also supports intrusion prevention and detection capabilities, especially with firepower. Firepower is what allows to treat ASA as what we call a next-generation IPS solution. It supports advanced features such as AMP, URL filtering, and much more. So we can also use the ASA to work as an IPS IDS. Another big thing about the ASA is that you can virtualize a single physical platform. You can buy a single ASA firewall and configure it differently with the aid of so-called contexts, where a context can be described as a separate virtual firewall that resides on the single physical ASA. Say I can have 3 different contexts for 3 different customers, or maybe 3 different departments that are managed separately and enforce a different policy. Of course, it is also possible to deploy the ASA in a redundant way. You can go for failover, which is generally an example of an active standby solution. Or alternatively, you can also deploy ASA in a cluster that allows you to combine multiple firewalls, all capable of handling the data packets. Okay, one of the first things that you will want to do as you work with a brand new ASA is going to be to set up its interfaces. And there are actually a couple different ways how you can configure interfaces of the ASA. You can go for physical ports, you can go for redundant interfaces, you may even build Ethernet channels or add sub-interfaces. But in the simplest case, in the simplest design, you will be configuring physical ports, possibly adding some sub-interfaces like on a regular router. Okay, so the first thing that we will have to do on the ASA, on its interfaces, is going to be to give them an IP address. As you can see, the syntax here is actually pretty similar. Well, maybe with the exception of the standby command. The standby command is going to be useful when you plan to deploy a failover, so add some redundancy to the design. But normally it's going to be the IP or IP version 6 address what you will have to issue to configure an address on the unit, on the interface. A very important component, part of the interface configuration, is known as a security level. And security level is generally used to distinguish between the trusted, semi-trusted, and untrusted interfaces. It's a decimal number between 0 and 100, where 100 is the most trusted value, describes the most trusted interface, and 0 should be associated with the untrusted interfaces. Now, any numbers between 0 and 100, this generally refers to semi-trusted connections, semi-trusted zones. And as we will see, the level itself is something that is really important because it affects the default filtering behavior of the ASA firewall. And I'm going to get back to this topic in this session. In just a couple of minutes, we will see the difference between those different numbers, how we set them up. It is going to affect the behavior of the ASA. That's for sure. Once we configure an address and a security level, we will also want to configure an alias for the port. This is needed to activate the interface and to activate it for data forwarding. And note that if you name the interface as inside, it's going to automatically assume a security level of 100, versus when you use a different name than lowercase inside, it's going to automatically assume a sec level of 0. It's not that important because you can always override those levels with the security level command. So we don't really have to worry about that, but just remember that the nameif command also automatically sets the security level. VLAN tag is optional. It's an equivalent of the encapsulation .1q command on iOS, where you specify a VLAN number. It's the same purpose here. It's just to tell what's the VLAN number you want to assign for the sub interface. So we can build a sub interface on the ASA using a similar syntax to iOS. Say you will choose an identifier for the port, like you will say gig1.50, and then instead of saying encapsulation.1q VLAN, let's say 50, you will just say VLAN and put the tag number like that. So you can run multiple logical ports out of a single physical interface, same as on iOS. And the last thing we will want to do on the interface is going to be to bring it up. Maybe let's quickly take a look at this. I've got a really simple topology that we will refer to throughout this session. We will now see how to perform this configuration on a live ASA. Interface gig00, I'm going to say, we're going to treat this one as our outside. So we will assume a security level of 0, versus gig01 is going to be treated as a trusted connection, as a connection to the trusted zone. We will give it a security level of 100. The ASA is going to be using the 20 as its IP address. We've got VLAN 21 on the right, on the inside, and VLAN 71 on the outside. So let's see how we can perform this basic configuration. I'm going to access the interface. Then I'm going to use the IP address command, and I will give it the IP. It's going to be /24. Then I'm going to say that it's going to be my outside interface. Note that the device tells me that it automatically assumes a security level of 0. If I now use the security level command, I can easily change this number to something else, but 0 is actually what I'm looking for on the outside. This is a physical interface. We will not be using any sub interfaces. So I will just say no shut this port. And we will now perform a similar configuration on the other interface. So gig01 is going to act as our inside. It's going to be 192.168.21.20, what I want to use on this port. Also /24. The alias for the interface is going to be now set to inside. Inside also automatically sets a security level. I used to overwrite the default number with security level command just to make sure that I've got the right number. Bring it up, say show interface IP brief, not show IP interface brief, but show interface IP brief. This command uses a slightly different syntax than the iOS, but I'm looking for up, a status and protocol. Okay, so let's double check this. Let's make sure that we've got basic connectivity on the inside and outside. I'm going to try to ping 7 on the outside and then 2 on the inside. I can get to my inside device. I should be also able to get to the outside router. We see that I have connectivity. It was a really simple configuration. The interfaces of the ASA are now initialized. Another thing we will now quickly take a look at is how to perform basic routing configuration of the ASA, to start participating in the control plane, to populate the routing table of the firewall, and also possibly other devices, to prepare the device for the data plane forwarding. Okay, as we will see, the syntax, the routing syntax is very similar to the iOS. We can build at static routes using the IP version 6 route or just route command for IP version 4. So for IP version 4, it's gonna be route, not IP route. But other than that, the syntax is gonna be pretty close. Now, what's gonna be slightly different is how you build a default route. So you could technically say use 4 zeros and then another 4 zeros for the mask, but you can easily abbreviate this with just 2 zeros. So when you say 0 space 0, it's basically an abbreviation of 4 zeros followed by 4 zeros. Notice that in any case, one thing that you don't see on iOS is that you have to tell the ASA what interface a given route should be added through. So with this configuration, when I say route outside 00 and then specify a next hop, this is automatically telling the ASA that the default route is associated with my outside interface. And we might actually quickly add a default route on our ASA. I'm gonna say that CSR7 is gonna act as the default gateway. Like if this was my internet connected, the edge router connected to the internet, just to show you the syntax. So it's IP version 4, it's not IP route, it's route. Then I'm gonna say that the route is to be added via the outside interface. The destination is the default route, and router 7 is gonna act as the gateway. Really simple configuration. Another thing you may want to do in terms of routing configuration on the ASA is to use OSPF or even OSPF version 3. The configuration is going to be very close to iOS. If we were to take a look at this on iOS first, it would be router OSPF. We could also give it a router ID and then say what interface we want to enable the process on. In case of the internal device, it's going to be 192.168.21. I'm going to say .2. And then I would be using the wildcard notation. Let's go for the backbone. And let's also perform a similar configuration on CSR7. I'm going to give it a different router ID. Okay, so here the syntax is going to be the same as on 2. These both are iOS devices. I will just use a different IP address. Let's now take a look at this on the ASA. What's gonna change over here? Well, not really much. I can still give it a router ID using the same syntax as what we just saw. I will still use the network command to enable the process, and I'm gonna enable it on 2 interfaces. Let's say I want to enable it on the interfaces configured that they made part of this a single subnet. Note what I'm using here. It's not wildcards, it's regular network masks. That's pretty much the only difference as it comes to basic OSPF configuration on the ASA. The only thing that's different from iOS, again, is the mask. It's not a wildcard, it's a natural, a normal, regular network mask. we see that the adjacencies were established. I should be able to double check this with show OSPF neighbor. So many times on the ASA, when you use the syntax for configuration and verification, you will notice that the only difference from iOS is lack of the IP option, or maybe IP version 6. This will be the major difference in many cases. Other than that, the syntax tends to be similar to iOS. If you're curious about some other routing options available on the ASA, it's still EIGRP and BGP. So static routes, OSPF, EIGRP, BGP, and version 6 equivalents. I believe also RIP. Let's double check if we can run RIP on this code. Yeah, RIP is still available. Even ISIS appears to be available in this code. So you've got really a lot of different options as how you can enable configure routing on the ASA as of 9.6. Now, a very important thing related to the ASA configuration is going to be obviously our filtering policy. Here, what is really important to remember is that by default, the ASA is going to block all communication to itself, to the box traffic, except for ICMP and maybe HTTPS, if this is going to be a physical box with factory default settings. So ICMP is allowed as the only protocol that you can use to talk to the ASA, but the thing is that it's only to the local interface of the unit. So from router 2, I should be able to get to Giga 1. Let's take a look at this. I'm going to go to 2 and I will say I want to ping the inside of the ASA. .192.168.21.20. Okay, I can reach this port, but even that I know how to get to the outside interface, I will not be able to ping 192.171.20. This is blocked by the ASA. Remember, it's just the local interface what you can get to with the ASA. So I cannot ping across the firewall. This is not allowed. And that's the only thing that is by default allowed to the ASA. If you plan to open some other ports, some other sockets, you will have to change the configuration of the ASA to allow for that. Now, when it comes to data plane filtering, we've got pretty much 2 rules that we have to remember about. As long as the communication is coming from a higher security level aside of the network, and it is destined to lower security level interface, it is going to be allowed. What it means is that if I were to telnet from 2 to 7, we should see that this is going to be allowed. We can actually quickly test this. Okay, can I get to 7? It says connection refused because my line config is not allowing those connections. I'm going to say no login so we don't have to authenticate. And I'm going to allow telnet and SSH. We see I am able to connect from 2 to 7. But because 7, router 7, CSR 7, is connected to the untrusted zone, so 0 is obviously lower number than 100. When 7 tries to telnet to 2, we will see this is blocked by the ASA. Okay, the router 2 to 7 was allowed because I'm starting from 100. So I'm starting from a higher level than the destination, than 0. I can do this. But when I try to do the opposite, I'm at 0. I want to get to 100. We should see that it's not going to work. even that 7 has a route, show IP route, it has a route to 2. We see that this is blocked. And it's not a connection refused message. We're getting a timeout here because ASA is silently dropping the packets. So this is now blocked by the ASA. And now the way you can fix something like this is with an access list. You would have to build an access list for a connection you want to permit. I'm going to call this access list outside in. And I will say I want to permit TCP packet from anyone to my router, as long as the destination port number equals to telnet. In this access list, I still have to activate it on this untrusted interface in the inbound direction. And that's the way I can do this. I'm saying that this is my access list, and I want to apply this ACL inbound on the outside, which means that it's going to be activated over here, and inbound means packets coming to the interface. So packets from 7 towards 2. With this access list, I just made an exception. I can telnet in the opposite direction as well, from 7 to 2, because I explicitly allowed this in my access list. If I didn't have this access list, we saw the traffic was blocked because it's going from that untrusted part of the network. Of course, this access list, it also has that implicit deny at the end. So if you want to permit some additional flows, you will have to make permissions here. And one final thing, one final word about management, about the administration of the ASA. Well, you can certainly access the ASA using the console port, which is going to be an example of the command line access. But if you plan to manage the ASA over IP for the network, you can either go for telnet or SSH, which is obviously still for the command line. Or as an alternative, it is also possible to use the GUI mechanism to control the firewall, which is going to be an over HTTPS connection. Okay, and I said over HTTPS because technically what we use to manage the ASA for the GUI is known as ASDM, Adaptive Security Device Manager, which is a special Java applet that you will have to install on your PC to connect over HTTPS to do the actual configuration. Now, a good thing about this ASDM stuff is that you can easily download it via HTTPS, via normal HTTPS connection using a browser. So you'll just browse to the ASA's IP address to download ASDM. You can also install it separately, do pre-installation. Once you have ASDM in place, you will be able to manage the ASA. There is going to be some configuration needed on the ASA to get it up and working, which is behind the scope of this session. Since I will not be showing you ASDM, maybe let's quickly take a look at the basic telnet administration, the command line access with telnet. Just remember that since the ASA does not by default allow any to-the-box traffic, we will have to tell it to do so. We have 3 commands that control management access. It's telnet for telnet, SSH for SSH, and HTTP for ASDM. Okay, so obviously I'm going to use the telnet command to show you how to do that. It's a really simple syntax. Assuming that I wanted to allow my inside device, router 2, to manage the ASA on the inside, the only thing I would have to say on the ASA would be to tell it that 192.168.21/, 24, let's say the entire subnet. I could be also more specific. I could say it's just for a single device, for a single IP address. As long as I see this address on my inside in the telnet connection as the source, I'm gonna allow the packet and process it to provide management access to the connecting client, to the connecting user. So let's take a look at this. Let's go to router 2. Let's try to telnet to the ASA 192.168.21.20. So we see it asks me for authentication to authenticate, versus if I were to do this from router 7, which is connected on the outside, this is not gonna work because I'm not allowing those telnet packets from the outside. Well, telnet is actually never gonna work on the outside unless you do telnet via IPsec tunnel, because the ASA, it treats telnet as an insecure protocol. So it's okay with telnet on the inside, but on the outside you're pretty much limited to just SSH and the SDM. But it would still require this command, require this appropriate syntax either for SSH or ASDM to allow the packets, management packets on the outside. In case of inside, you can do telnet, SSH, and ASDM. Of course, you still need those commands to get it up and working. Right, guys, I'm gonna go ahead and call this a day. Thank you very much for attending. At the end, I want to mention that we have a lot of different learning paths at INE, each covering a different aspect of networking and other IT-related technologies, such as cloud, such as security, programming, and many more. I definitely encourage you guys to visit us at ine.com to check out the details. Thanks again, and I'll see you in other videos from INE.